Okay, this is 14.5 dilations or stretch. This is the last packet, last lesson packet. Or you're going to get project and final review packet, but the lesson packet, this is the last one and the last video. Not necessarily, I may do a solution videos, but lesson videos, this is the last one. So rejoice. All right. Plot a triangle ABC with coordinate 2, 1, 4, 4, and 1, 5. All right, so let's do this. 2, 1, 4, 4, and 1, 5. Okay, so this is A, B, C. Then extend the line OA, OB, and OC so that OA dash is to OA. Okay, so this is O. Okay, O is the origin. So right here, A dash. Okay, so the OA dash is to OA. Sorry, you couldn't see. All right, so OA times 2 is OA dash. So here is BO. So I'm gonna go 4 by 4. This is B dash. And here is OC. So you're gonna go, this is C dash. Okay, so these are all true. OA dash is 2OA, BO dash is 2OB, and OC dash is 2OC. So if I connect, so the original triangle is right here, and the new triangle is over here. Okay, so it kind of looks like a 3D, like the triangle is coming out from here. But anyway, draw a triangle A dash B dash C dash. What relationship do you observe between triangle ABC and A dash B dash and C dash? What do you see here? What relationship do you observe? What do you think? So the things that you can think about is this isometry. What happened to the distances between points? What happened to the angle measure of each angles? And what happened to the orientation? Okay, so just whatever you thought about, just keep it, and then we'll review it later. Okay, so objective is locate images of figures by dilation. And stretch or scaling. I think stretch is probably a better word, but anyway. Right, so reflection, translations, glide reflections, and rotations are isometries. Isometry is congruent mapping. Okay, or congruence mapping. Oh, it was already there. All right, in this section we consider transformation related to similarity rather than congruence. It is called dilation. The dilation D O K. So D for dilation, O is the center right here, has the center O and non-zero scale factor K. Okay, so stretch or scaling, this is a scale factor. So dilation center O with scale factor K maps any point P to a point P dash determined as follows. If K is greater than 0, P dash lies on ray OP, and OP dash is K times OP. So if we go over here, the K, this is actually dilation of O2, right? Dilation of center O and scale factor of 2. Okay, so this distance is this times 2. So that's that. This distance is this times 2, and so forth. Okay, so that's what this is. The distance between O and P dash is K times the original length. Okay, if k is smaller than 0, p dash lies on the ray opposite OP, and OP dash is absolute value of k times OP. Okay, but the ray opposite, it's gonna go in the other direction. There is a here, like this. You see this? This is OP, and OP dash went the other direction because it's negative. Okay, so that's one. This is the original ray direction. If it's negative, it's gonna go the other direction. Okay, already, and the distance is absolute value of that. Okay, and the center O is its own image. Okay, and if absolute value of k is greater than 1, then dilation is called expansion. Like this one, the k was 2, so this ABC triangle and A dash B dash C dash, this is bigger, right? So it's expansion. If the k is smaller than 1, like say 1/2, it's gonna go here, right? And right around here. And if it's 1/2, less than 1, it's still positive, so it's gonna go to the same direction, but this is smaller, right? And it's called contraction over here. Contraction. Okay, so there is a situation where k is positive, k is negative, it's gonna go the other direction. But also, if k is bigger than 1, then it's gonna get bigger, and if k is smaller than 1, it's gonna get smaller. Okay, so the positive and negative determines the direction that it's gonna go, and whether it's bigger than 1 or smaller than 1 makes it either expansion or contraction. Okay, all right, and developing leaf undergoes an expansion, keeping approximately the same shape as it grows in size. So these leaves are kind of similarity, expansion, dilation there. Okay, so find the image of ABC under the expansion. So we just did this in the warm-up. Okay, so that's what it was. And let's look here. Find the image of RST under the contraction center of O and 2/3. Okay, so this was the original T, and then this is 2/3 of this distance. This is 2/3 of this distance, 2/3 of this distance, so it's contraction. Okay, and in example above, you can prove that two triangles are similar. How are the areas of each pair of triangle related? So if these triangles are similar, because direction is a similarity mapping, and if this scale factor is 1 to 2/3, what happens to the area? You remember this? This is chapter 12. No, chapter 11. It's the area of the 2D figures. The chapter 12 is the 3D figures. So what happens? The scale factor is 2/3, right? 1 to 2/3. So the area is going to be 1, 2, 4/9. Okay, you have to square it. If it's a volume, then you gotta cube it. But this is how the areas of each pair of triangle related. The ratio is 1 to 4/9. Okay? All right, find the image of figure F under contraction of... Now, here it says contraction. It may not tell you that on the problem. Find the image of dilation under and just this, and you have to know when there is a negative, it's going to go the other direction, and if it's less than 1, it's going to get smaller. If it's less than 1, it's going to get smaller. If it's bigger than 1, it's going to get bigger, and so forth. Okay, so this one, and you know this flipped, this title is flipped because it have to be, each one have to be through, let's say this tip of the tail, right? This have to be on the straight line, right? Through the O. You have to and then this eye to eye have to be also a straight line, and this distance have to keep the ratio of, in this case, 1 to 1/2. So this distance have to be 1/2 of this, and so forth. So that's why the image flips. If taro is not flipped, and then like, you know, it's like this, here is like this, and here like that, and then it is like that, then this, if you connect the tip of the tail to tip of the tail, it's not gonna go through the origin of gyration. So that's why it flips. Alright, similarity mapping. If the scale factor in example 3 was -1 instead of -1/2, the figure f dash would be congruent to figure f, and the transformation would be isometry, equivalent to half tan. Yeah. So if this one wasn't smaller, but it's the same size because it was the dilation center of -1, then this is just rotation, right? Or half tan. That's what it's saying. Okay. In general, however, as these examples illustrate, dilation do not preserve distance. Therefore, the dilation is not an isometry unless k equal 1 or k equal -1. If the k is 1 or -1, it is rotation. Okay. Actually, -1 is half tan. -1 is half tan. And the positive one is just mapping to itself. So it's not even rotation. But a dilation always maps any geometric figures to a similar figure. In the example above, ABC is triangle A dash B dash, and so forth. Okay, so it's a similarity mapping. So this is a theorem. Don't need to worry about that. You just know that dilation maps the triangle to a similar triangle, and it preserves the angles, right? Preserve the angles, and also preserves the ratio of the lengths, but does not preserve the actual distance or the area. Okay, distance is going to be the scale factor. Area is going to be the square of the scale factor. What about orientation? This is TRS, and then this is FP. The orientation doesn't change. Okay, orientation does not change in dilation. Alright, and here are corollaries. Dilation maps an angle to congruent angles. Dilation maps segment to a parallel segment, k times is wrong. Segment to a parallel segment, k times wrong. Okay, parallel, this is what it means, it's parallel. These are parallel. These are parallel, see? Parallel. And even this one, you see these lines are all parallel, right? Parallel. Okay, so that's one of the corollaries. And dilation DOK maps any polygon to similar polygon whose area is k squared times as large. Okay, so the area is a square of that. Okay, a diagram for the theorem above shows the case in which k is greater than 0. You should draw the diagram k is smaller than 0 and convince yourself the proof is the same. Right, you should try that. If you know what, you don't have to. As I told you, you don't have to read this proof. Okay? Right. Theorem 14.5 can also be proved by using a coordinate. To do this, you see the center dilation at the origin and describe DOK in terms of coordinates by using DOK. So the dilation of center O and multiple K maps the X and Y to KX and KY. Okay? It's an important point right here. Okay? You can see that this description satisfies the definition of dilation because O, P, and P dash are collinear with slope, and OP dash is absolute value of k times of p. Use the distance formula. We don't need to do that. Okay, I'm not gonna make you prove this. I just want you to kind of generally understand that you can get a distance formula, right, with these 2 points. And then you can get the distance formula here and see if this is k times this. It's easy, right? You can do these points and then 0 to this to get a distance formula. And then you can also get this slope and then this slope. And then actually you can do this slope and this slope, and since this point is common, this slope are the same, and they have to be collinear. Okay? Alright, practice. Sketch each triangle on the chalkboard. Well, you can just do right here. And sketch with image under given direction. Okay, so this is direction of 3 times of center O. So you're gonna go 3 times this distance. 1, 2, 3. You dash. 1, 2, 3. W dash. 1, 2, 3. V dash. Okay. So that's that. Okay. And this is center S of 1/2. Positive 1/2. It's gonna go here. It's gonna go here. And this one's gonna go like this. And like that. Okay, so these lines are supposed to be parallel, so you kind of like eyeball it. Okay, these are supposed to be parallel. You remember corollary 2? Right? Right, and this one, -2. So -2 about E, it's gonna go 2 times in opposite direction. So if this is 1, you're gonna go 1, 2. So this is gonna be R dash. And if this is 1, it's gonna go 1, 2. You should use a ruler to get the actual distance. I'm just kind of eyeballing it, but 1, so that's 1 and 2, like that. And that'll be P dash. And if you connect these, right? Okay, so these are parallel. And wait, it's a straight line, so these are not parallel. These are parallel. Yeah, they're supposed to be parallel. No, this is parallel. So yeah, this is parallel to this, and this is parallel to this. Should be, if I didn't done correctly. Yeah. Okay. You try this one. Homework. This is negative, so it's gonna go, and then this is the center, right? So that means n is not gonna move. N is not going to move, it's gonna stay here because it's on the center. What happens to where L is gonna go? It's negative, so it's different direction. And this is so small. Is it 2/3? Okay, so do as a 2/3. So the L is gonna go, 2/3 is about this length. It's gonna go about that length right here. Okay, so you do M and draw a triangle. What else we got? 10, 11, 15. Next. All right, let's do a few more. Okay, find the coordinate of the images of point A, B, C and the direction D0, 2. Right, you can do this one. You can use these points here and do this if you want. Find the image of XY under D0, 2. Okay, so this one's interesting. You don't like this, right? So what happened to X? So let's just call this is XY, right? And then if you do 2 times, it's gonna go 1, 2, right? So what happened to the X value? This was X value. This is 2x. This was Y value. This is 2y. So this one is going to be 2x and 2y. Okay? Does that make sense? What direction with center O maps A to B? Right, so the distance is half, right? So this should be D of center O of 1/2. It's still the same direction, but the half the distance, so it's 1/2. What direction with center O maps C to point -6? Okay, so I want to try this for homework. Okay, and find the coordinate of the image of A under DB2. All right, so since this is ours, I'm going to do this one, and let's do 10. Okay, so if you'd rather do it bigger here, you can put the points and practice here. Okay, so I think we should do that. Let's just erase this and find the coordinate of image of B under D3C and DC3. Okay, so B was 2, 2. Okay, and then where is C? Where is C? C is over here, 3 and 0. All right, and so this is the center of direction, and then you want to go 3 times image of B under, so it's gonna go 1, 2, 3. Right, that's the 1, 2, 3. So the distance here is 3 times the original, right? So this is going to be 0 and 6. Okay, so you do this one. So this one you're doing A and then sentence this and 2 times. Match each scale factor in, okay, you can do this one. You're just matching, okay? Describe the direction. You can do this. If center S has a radius 4, describe the image of a circle center S under DS5, and I'm going to try this. If point A is on line K, what is the image of line K under DA2? Right, so let's do this one. The point A is on line K. What is the image of line K under direction A times 2? So line doesn't have any limit. So if you go 2 times point A is on line K, what is the image of line K? So it's still line K, right? Because line doesn't have a length, right? So I think it's still line K. Right, the dilation of D03 maps PP dash and QQ dash. If OQ is 2, find, alright, so OQ is 2 and it's 3 times, so it should be 6. PQ is 7. Right, so there's O, P, Q, and 1, 2, 3, so this is P dash, and 1, 2, 3, so this is Q dash, and this is what's P. PQ is 7. This length, it's still a scale factor, so this should be 3 times, right? Because this is 1 to 3, so this should be 1 to 3. That's 21. And if this distance is 10, OP, what is, wait, here is 10. So what is this, right? Okay, so you remember this, this to this, the whole thing to this should be, no, I'm sorry, the whole thing to this should be 1 to 3. So this should be 2 to 1, right? Because this is 1, 2, 3. This is 2 to 1. So OP should be 5. Because this is 2 and this is 1. And that's 10. So that's 5. Okay, I think that's it. This was a long video. Sorry guys. But that was it. So this is the last lesson video. Rejoice!